This is SSCA, Seven Seas Cruising Association, Cape Hatteras for cruisers, snowbirds, and passagemakers. This is a March 9th, 2022 presentation by www.ssca.org. I am Joan Conover, President of SSCA this year and your host. What is SSCA? We're a worldwide association of cruisers. We're a nonprofit, cruisers helping cruisers and the community we visit. What is Cape Hatteras? It's a cape, a landform, one of the three great capes of the world. It's impacted by weather. We have circulation, currents. We have a Gulf Stream and landforms, the shelf and barrier islands. There are Cape Hatteras inlets we'll discuss, research buoys, and wind farms that are beginning to impact some areas of getting to the Cape or around the Cape. Cape Hatteras is a unique landform. A cape is a high point of land. You'll see the little fork and the orange spot. That is the tip of Cape Hatteras. The light green faded areas, those are barrier islands. And the cape is a point that extends out into the water with shoals or those islands that are very difficult to see because they're being eroded away by the currents. Examples of the major cape land masses: Cape Horn, Cape Good Hope, and Cape Hatteras. Of all of those, Hatteras is one of the most dangerous. Capes have converging currents from large masses of water. Salinity and temperature make a big difference, and Cape Hatteras has the southern flow of water that is salty, the hot temperature that the Gulf Stream brings, and then the northern flow of currents that are non-salty and very cold. These shelf currents suddenly converge with the deep ocean currents of a big drop-off. So let's talk a bit about weather and the patterns we have been watching spring and summer. Many people have wondered what has been going on because there are no real breaks or easy 3-day passages to get around the Cape or to passage. And it's been a very difficult year. Okay, weather patterns. This is year 3 of La Nina's impact. And in the center, you'll see a diagram of the U.S. This is a diagram from NOAA showing a typical La Nina pattern, and we have seen that. The West Coast is wetter. The southern Gulf Coast areas are drier, and the East Coast is warming. The storms go over the blue line, and that's where all the lows travel, and we are watching that. And you've noticed that there's more snow in the Northeast this year. That's because of La Nina. Now, March 15th, NOAA webinar will be hosted by their weather service, and SSCA speaker, Commodore Frank Smith, will be talking on a panel. They'll be talking about electronic graphic chart plotters and iridium and how to communicate offshore to get the materials that are transmitted from NOAA to the general public. La Nina has major climate impacts. And if you look at the slides that you see, you'll see cool is green, or cool is blue. Green is very wet. And remember, Australia has been having floods, and there have been floods in the Far East. The light blue, cool and dry, that's where La Nina shows up, or El Nino. El Nino is hot. La Nina, the child, is blue for cooling. You can see South America, and especially Trinidad, had a lot of flooding. It's wet. And you can see the southern Gulf Coast areas were a bit dry, and the northern areas and West Coast were a lot wetter than this slide shows, but they were wet. In summer, if La Nina does not change to El Nino or neutral, this is the pattern you will see, where you will see cooler in the tropics, average in the US, and in the Far East, it'll be cooler, drier for Australia. It changes the patterns of how weather features flow across the Pacific and the Atlantic. With La Nina, these storms track over the middle U.S. and North Carolina, so Hatteras is impacted by La Nina. And for weather questions, I will defer to the end of this session. So let's talk Hatteras currents. Let's talk circulation. Currents, by the nature, this is a cape, are around Hatteras. They converge at this point of land. There's first the Gulf Stream. Everyone knows the Gulf Stream. And on that little chart at the far left, you'll see the orange strip that is the Gulf Stream and the meanders, the wiggles, according to NOAA. The Mid-Atlantic Bight, or MAB on that chart, it's north of Hatteras, that's shelf water, and it's cool. The Southern Atlantic Bight, SAB, I didn't name this, is shelf water that's warming coming up from the southern oceans. And then there is that purple shelf break jet, which is a very sharp current. And we are going to go look at that small box in the center of the screen to talk about that particular area that has pieces of Gulf Stream, slope sea gyre impact, your western boundary currents there, shelf break jet, Hatteras front, which is just the edge of the tip of Cape Hatteras, on top of the shelf there, both shelf waters. We'll look at this frequently and look at the smaller box frequently in the next slides. So what is this diagram on the right? This is the diagram of the process exchange at Cape Hatteras. This is a research project that was done by the University of North Carolina, Dr. Seam, and NOAA. And in it, they mapped the Gulf Stream, that orange strip. It shows in this slide the deep sloped sea gyre, which is north of the Gulf Stream, and it's something you have to be aware of as a feature. Then you see the purple shelf break current, which is important because you've got several knots of current from that. You see the green, very faint inside the box, Hatteras front, and then on each side, the shelf water currents, either from the mid-Atlantic or the southern Atlantic areas. So the northern circulation area has a gyre, and you can look at these currents coming along. The blue current, or the blue arrow, show the shelf current that is coming from the north, and it's cool. It's cool water. It's coming from the Labrador current injection into that northern area, and it can be 1 to 2 knots of a flow of water from the north as you're coming out of the Chesapeake. The southern circulation area is south of Hatteras. You can see there's a countercurrent, or a current that complements the Gulf Stream, but in between that countercurrent and the Gulf Stream is a current that you can actually use to ride south if you're in the next slides, I'm going to be giving some information. This is not for navigation. This is from personal experience. I suggest everybody research Hatteras, research the weather, research the currents, and stay current. You cannot wait a day or two. You have to have your immediate weather before you decide to round this cape. And if you're coming from offshore, I'm having this little arrow come up, and it shows one entry point if I was going from, say, Bermuda, or from a straight run from Antigua. I would probably look at coming here through here in this particular area to catch the outside of the gyre to get up to New England. Or if I was coming from Bermuda to the East Coast, I might cut a little closer and go into the Chesapeake from this outside point, keeping me out of Hatteras. I can go a little closer to Hatteras, but I look at where the stream is running to and what the wind is doing, and I've got a day to get across. I plan a day. So let's look at a bird's eye view of this area of consideration. You can see I've kind of mapped that little work box on top of Hatteras. You can see it's pretty intense there. And here is a little blow up of that. So it shows the currents coming down the Gulf Stream and how this all interacts. So now let's look at this a little closer. Your approach to Hatteras should be based on weather and your boat and your knowledge. You don't have to go around Hatteras. You can do the Intercoastal Waterway. But if you're going to round Hatteras, these are some of the factors you should be aware of. You see the Gulf Stream? And on the right, you'll see a blow up. This is a very important document or diagram to look at. The shelf break current comes and whacks into the Gulf Stream. The shelf current from the north, that cold water, hits the Gulf Stream. You've got southern warm water coming up and counter current against the north coming to the south. And then the Gulf Stream is the almost this mixing bowl. And you have the Hatteras Shelf. Now there's another feature. Shelf to a fast jet. And here's a blow up of that again. I don't know if you can see it. Here's a Diamond Shoals. You right in this particular area, and I will show you a chart, is where there's almost a drop off. If you look, you'd think underwater waterfall, but that is when that becomes a jet and it just shoots out of here. And you can have 2-3 knots or more. And if you've got wind against the sea, it's not fun. Now, rounding the Cape offshore. This is my advice, but we've rounded the Cape many times, my husband and I on Royal Tiger with our kids, dogs, and whatever. And I like to be comfortable. It depends on weather and wind and squalls and currents, the direction of travel you're doing and your destination. You need to give this body of water space and respect. We have had so much fun going around Hatteras, and we've had some times where it hasn't been fun. And when it hasn't been fun, it's been where I've had that funny feeling saying, do I really want to do it? Give space and respect for this body of water, this Cape. If from offshore, cross the Gulf Stream, anytime, cross the Gulf Stream as quickly as in favorable winds. Timing depends on your boat speed, but we usually figure from leaving, say, Chesapeake Bay, 12 to 18 hours from the bay. Then plan a day to transit the Gulf Stream. You reverse that pattern for Western travel. It's a 3-day window. You do not go into the Gulf Stream with a low pressure system forming that may impact you as you're rounding this body of water, where this block is, or even anywhere in the Gulf Stream. You really don't want to be caught in a low. Always pick the best transition of your Gulf Stream route based on route, winds. Check your squalls too, because you could look perfect winds and you got squalls. And also know where your eddies are and how the currents are affecting those eddies. There's nothing more fun than belting out at full speed out of the bay, getting up, past into the Gulf Stream, getting the other side and stopping because you entered an eddy with a opposing current of 4 knots and you weren't going anywhere. One of my best routes coming up from the tropics was going the old Bahama Channel to Florida, waited at West Palm Beach, waited for the right windows, thanks to Chris Parker. And we had a 3-day run. We rode the Gulf Stream all the way north, but we watched the weather, and I stayed on the west side so I could peel out if we got into a weather problem. But I've used that Gulf Stream riding from the south very successfully. You just don't want to be in it in weather. Same from coming from the north. You don't want north winds. Cape Hatteras currents, near shore rounding. Here's some experiences that we've had. First of all, the barrier islands north of Cape Hatteras become a lee shore in strong north and northeast winds. So anything happens to your boat, you're going to be blown onto the shore. And there's an automatic push onto the shore when you're there. So if you fall asleep and aren't paying attention and your boat ends up on the sandy shoals there, you'll have to get it off somehow. But it can be done. Now, south winds against the south. If you have opposing winds against any current, it's bad. Right along the shore from Chesapeake Bay down to Hatteras, you can get a really rough chop because you've got that north current feeding down and a south wind against that makes it choppy. It's not terrible, but be aware that in the shallower continental shelf areas, you can get that chop. North winds do support your southerly passage from the bay, and you get a couple knots of speed because of the current. But round in the Cape, you can experience that washing machine chop off the Cape. And if it's strong north wind, you don't do it. North and northeast winds against the stream cause very steep and uncomfortable seas. And the effects can spread to near shore because they kind of migrate and can wrap around landforms. And I'll show you that in a minute. And off your Hatteras inlets, effects are possible. Oregon Inlet can have tide going out, wind blowing against from the west going out, and you'll feel that like a river pushing you if you're near shore enough to be affected by that. And the opposite is true. If you have a strong east wind and the tides are going into the inlet, I've had boats actually almost get sucked into Hatteras Inlet, and that is not a good place. There's no water there if the tides are out. And if the tides are in, it's local knowledge only, very shoally. It's not a place to go. And that is Oregon Inlet. Be inside the Gulf Stream when you're rounding the Cape, either going north and south, if you're doing the nearshore rounding. Don't get out into the Gulf Stream. Stay inside so you can peel out and get to an exit point if you have to. North going vessels, you should expect a 1 to 2 knot flowing shelf current once you round Cape Hatteras. That's where you saw those currents coming in. Just be aware it happens, and you don't go as fast as you'd like if you are going against the current and a slight north wind. If no wind, you'll just go against current. South wind will give you chop, but you will have a better speed. Watch for eddies from the Gulf Stream. I'll show that later. And consider the tidal effects of mouths of bays and inlets. Again, I mentioned about Oregon Inlet, but that goes for all the inlets. And if you don't like the weather and you have to get somewhere and you can't wait for the perfect timing to cross, and your Chris Parker or your weather router has said, oh, wait for another 7 days, you can always go the Intercoastal Waterway route to Beaufort and then cut across the Gulf Stream there, or continue further down the coast. For my personal preference, I would give yourself a break, pick good weather windows. It makes a much happier crew on board. I'm going to show you a weather example from Windy, because I know all of you can reach Windy, the waves, currents, and Gulf Stream. Several systems and apps provide wonderful weather features. Predict Wind, I really like that when it's model-based. It has the chat capabilities, so other boats around you can chat if they have Predict Wind. You can track each other, and you can stay in touch. Predict Wind has some attractive new features, and we appreciate the work that they have been doing. Now, here's windy weather for a baseline. Here we have East Coast US. You can see the green is from winds from the north. You can see the storm has just kind of lifted out a little, but you can still see there's some higher winds and whatnot. Yes, you could get south easily from the bay, but where do you go from there? Because if you have those nice north winds, the minute you get to Hatteras, or even close to Hatteras, remember we've got that those shelf currents, you are going to get waves. I do not like northeast waves at 9 feet, not the flat ones. And if you look a little further down on the right, you can see where the current is, and you can see that you've got a southeast 4 knot, half a knot current. You've got currents from the north. You've got some currents coming from the south. You've got a washing machine. This is the same date and time. I just picked Windy, just picked a day and looked at it. It could have been a slide of showing how wonderful it was. This, unfortunately, was not the most wonderful time to round Cape Hatteras. Now, I'm going to show you some Gulf Stream images and where to view data. Your National Ocean and Atmospheric Administration, NOAA, has wonderful and free charts that you can access from their website. And I'll wait for a second if you want to write that down, but all you do is search NOAA and Gulf Stream, and it probably will pop up in a Google search. And in this, you will see the blue is cold, green is cool but warming, and then orange is hot. You'll see some little bubbles, and those bubbles are are actually circular eddies. And I'm going to show you another slide that even shows that even better, because this is a complicated piece of water. Jennifer Clark's Gulf Stream. She does a marvelous job. She's retired from NOAA. Excellent analysis of the Gulf Stream. She does this every day. We're the same age group, so she is really dedicated to this, to the science. Note that the clockwise direction, the warm eddies are north of the Gulf Stream. You'll see those little circular areas in blue. Counterclockwise circulating cold eddies, they go the opposite way, or cold eddies, CE, are south of the Gulf Stream. And those are in green and yellow. I will show this blown up. Continental shelf water she has in that dark blue, and you can see that up to the north. And slope water is in light blue. Chris Parker at Marine Weather Center subscribes to her information and uses that for a lot of his knowledge of the Gulf Stream. The next slide is a larger view of the diagram. And remember, the warm eddies are north, cold eddies are south. One goes clockwise, one goes counterclockwise. So here's the larger, and she's marked Gulf Stream, warm eddy, cold eddy. This is an example from 1917. It's not 2017. It's not today image. But you can see the Gulf Stream, you can see all those little legs coming out and either curling to counterclockwise or clockwise. And you'll see the little protrusions coming out. What's important about that is not to be on the wrong side of a counterclockwise or clockwise eddy when you want to get somewhere. So you kind of have to know where they are. I mark them on my chart. We look at that, and if we find we're going somewhere, and all of a sudden I've slowed down, stopped, my boat is hard to keep on the route. The autopilot's not happy. I think I've probably hit a countercurrent of some sort, and I will very carefully test to see where my boat speed increases without changing the boat speed. I will just kind of change the helm till I can test and see which way the current's really going, and then work my way out of it. You want to get out of those as soon as you can, unless you want to ride one. I've ridden eddies. They give you an extra knot or two of speed, but you have to know where they are. Now, the mixing bowl, I want to remind you that the washing machine is off of Hatteras. And there's that diagram again. You see the Gulf Stream, shelf waters adjoining, shelf break jet. Now, rounding the Cape. Some discussion on routes, barrier island inlet change, Hatteras weather and research buoys going into place, and construction at the mouth and in the Chesapeake Bay. Now, some routes around Hatteras, I'm not good at charts, and this one, probably the arrow shows it, but you can have a route on the ICWs on your left. If you want to come up from the south and head into New Bern, you'd be coming from the area. As we're looking at the lower left, you'll see the area pointing towards the south of Hatteras. You'll see an arrow of circular rounding the Cape. Offshore, you're going to be staying away from the Cape. You don't want to be in that mix of currents. And if you look at some of the Peach studies, you can see where to stay away. And then coming out from Norfolk, you may go out to Bermuda, which keeps you away from the Cape, and you will go to Bermuda and then drop south. Or you can, I didn't put the arrow here, or you can come along the near shore and round the Cape, staying between, safely away from the shoreline and safely away from the Gulf Stream, in between the two areas. Here's what a chart shows. This is a raster chart, and the circle, and the big circle is where the sudden drop and the Gulf Stream goes over, almost looks like a waterfall going over this drop, and then it becomes a jet. The little circle up on the left side, that is Hatteras Inlet. I will talk about some changes there. I don't recommend using that inlet any more than I do the Oregon Inlet, and frankly, any of the inlets until you get to Beaufort. Now, this blue arrow shows kind of the ending of the continental shelf, and it drops from 33 foot almost to 2,000 well, there is 32 fathoms to 2,000. It just drops a lot. Fathoms 6 foot. Cape Hatteras inlets. Okay, Cape Hatteras inlets. Shoal charts may not be updated or accurate. Unless you have local knowledge, you don't use them. And you need to pick exit points as you go around, just in case. People will start to round the Cape and something happens and they need to find an exit point. At least Cape Lookout or Beaufort, South Carolina are places you can go in. There is a new Hatteras connector, a dredged area for the Hatteras Inlet. There's been some major changes there. Buoys are missing and they've done dredging, but it's only in some areas to 6 foot at mean low tide. I'll show you a diagram of that. The Oregon Inlet is notorious for rage and weather and tides and is shoaled. I don't recommend you going to Oregon Inlet. They have a wonderful view, big fishing dock or restaurant there, and people like it, but you don't come in on low tide, and you really need to come in on good weather. The U.S. Army Corps of Engineers dredge these inlets. Oregon Inlet, not so much, but the Hatteras connector, they did a lot of work. Markers have changed. Small boats can use these inlets with local knowledge, but not suggested for most cruising boats with any draft. And next, I'm going to show you what changed at Hatteras Inlet. It's been advertised, just don't go there. Here is the inlet dredge map for the Hatteras connector. You can see the fat boat area down there is where the ferry is that comes in and out, and I'll show you that dock in just a minute. But here's the new Hatteras connection dredge. And I'm just showing you this. I'm not even putting it on the map or where it's at, but you can see that if you go part way up, you'll see where it gets into the, 4 and shallower for the dredge area. This shows so much. I don't know how long it will stay open, but they seem very happy that they've made this a Hatteras connector, a new waterway into Pamlico Sound. I think it's mainly for fishing boats. You may be able to go in, local knowledge, I would suggest, or at least talk to someone to see if they've gotten through and what's happened. Now, one option, if you have a problem going around, is Cape Lookout. The very bottom of Hatteras, and there is a sand spit and then a bight right behind Cape Lookout. I would get updated charts and guides and use common sense for this anchorage. You've got plenty of room to anchor up by the spit. But this is coming in here, you need charts, but you have good water and you can anchor. There's also a dock and a walking area, and a lot of party boats on the weekend. Now let's talk new objects in the water of Hatteras and Chesapeake Bay. First of all, there's some new research buoys that have gone in this year and next. And then there's stationary objects under construction. The buoys are in construction off Hatteras, but off the mouth of the Chesapeake Bay entry, 27 miles out, they're putting in 178 wind turbines. That's by 2026. So it's going to be a continuous construction from now, where they have put in 2 turbines, to 2026. And I'll talk to that a little bit. Now, Mid-Atlantic Bight, Pioneer Array, the research buoys. What you're looking at is Hatteras. You're looking at 2 boxes. The red box is for where 11 buoys, weather buoys, will be anchored. The green box is for 3 gliders, and they're autonomous. They go underwater. I don't think they'll affect us. Well, if you have kids that like to fish, that might, or you may see something big under your depth finder. So here's the Pioneer Array and the glider location near the Gulf Stream. You can see where it's at. Red is the buoy, green is the glider area. And on the right side, you'll see the location. They're doing a lot of research trying to figure out what's going on, what changes are happening with the Gulf Stream. We will be able to address the data, receive the data from these buoys. So 11 buoys going in will help give us a lot of detail of what's happening, exactly what's happening with the mixing bowl area of Hatteras. What does this look like? There you got one. That's what you're going to see. They're well marked. They're on AIS. You'll see a definite signal on your radar. and just be aware they're there. I'm not sure when they will be put on charts. We've asked Aquamaps, who has identified, is aware that they're going in. These are not considered permanent, they're relocatable. So if they aren't put on the charts, it's because they're considered relocatable. But we'll try to get diagrams of them when they come in. Now, what does a glider look like? Big fat fish. And they stay underwater and supposedly will be meandering along the seafloor. Just be aware that's what they look like. So if you find one, you know it belongs to NOAA, and you can call them, I guess. Chesapeake Lower Bay. Construction's ongoing for Hampton Roads Bridge Tunnel and Chesapeake Bay Bridge Tunnel. So the mouth of the bay has barges, cranes, lights at night, look like Christmas trees. And there's construction for both tunnel entrances, both the Chesapeake Bay Tunnel and the Hampton Roads Bridge Tunnel. Hampton Roads Bridge Tunnel has major work being done. They're building a second tunnel. Well, they call it third tunnel, but second tunnel on the shore side of the current Hampton Roads Bridge Tunnel. So they have barges, they have big tunneling machines. There's no problem going through the entry. That's fine. You just may have barges off and on in different places. And Willoughby Bay, the anchorage there is now got a lot of barges and some very large concrete pillars. I would not recommend entering there. Federal Registry has a list of changes for the anchorages for the bay, and I expect those are on the maps as well. You can expect those working barges and crane not only inside the bay, but also outside, and they'll be working at an offshore location 27 miles from the mouth of the bay. This construction for the wind farm will impact vessels. They may have closures and exclusion zones set up during turbine installation. Notices will be sent out by U.S. Coast Guard, local notices to mariners. We don't think that's suitable because you have international boats coming in that may not be aware of what this looks like. And I'll show you some pictures. Here's what to be aware of for wind farms. It's a privately owned company, Dominion Energy, and they're installing, here's one installed for a wind farm, wind turbine, 27-foot clearance to water from blades. They have one installation ship that will be doing the 178 installations. Here's where this is located. You'll see the red circle is the major buoys are coming into the mouth of the bay that we all point to when we're coming in from offshore or coming north. There are currently 2 turbines in place on the northern side, the triangle closer to the bay. There are underwater cables. There's a platform. 126 more are planned. The navigation rules aren't clear yet. It needs some expansion, I would think. And I think they have had to do some geoengineering to get to through the sediment to the bedrock to put these turbine shafts into place. I don't know what that has done environmentally. There are no reports. Here again is the phase 1 with 2 turbines in place, 27 miles offshore, and then the lease area increases going to the south. Completion date is 2026. They are planning to put in ATONs or contracted with sea lights, and will provide local notices to mariners. Port Authority, Coast Guard, and the U.S. Navy are informed. More information is at www.coastalwind.com. And that's a Dominion Power site to describe this project. So this is what this kind of looked like with 2 of the wind turbines in place. You have a stationary ship for construction and cranes, and then the completed one has standalone, and that's what you'll be seeing them staged that way. Back to the shore from the terminals, they have a platform, and they have underwater cable that goes to Virginia Beach. Just be aware that cable is there. I don't know how deep it's been buried. So I want to thank you for